Welcome to the fascinating world of quantum chips. Today we'll explore what makes these tiny devices so revolutionary. Unlike traditional computer chips, quantum chips harness the power of quantum mechanics, allowing them to process information in ways that were once thought impossible. As we begin our journey, imagine a future where computers solve problems in seconds that would take years for classical machines. Let's dive in and discover how quantum chips are changing the landscape of technology, starting with their basic principles and moving toward their incredible potential. Quantum mechanics is the science behind quantum chips. It deals with the behavior of particles at the smallest scales, atoms and subatomic particles. In quantum computing, this means using quantum bits or qubits, which can exist in multiple states at once. This property, called superposition, is what gives quantum chips their extraordinary power. By leveraging quantum mechanics, these chips can perform complex calculations far faster than traditional chips. Understanding this foundation is key to appreciating the magic of quantum chips. Qubits are the heart of quantum chips. Unlike classical bits, which are either 0 or 1, qubits can be both at the same time thanks to superposition. This means quantum chips can process multiple possibilities simultaneously. The result, massive computational power for certain tasks. Qubits also interact through a phenomenon called entanglement, which links their states together. This unique behavior is what sets quantum chips apart from anything we've seen before in computing. Superposition allows qubits to represent both 0 and 1 at the same time. Imagine flipping a coin and having it land on both heads and tails simultaneously. This ability lets quantum chips explore many solutions at once, making them incredibly efficient for certain types of problems. Superposition is a fundamental concept that unlocks the true power of quantum computing, enabling breakthroughs in fields like cryptography, chemistry, and artificial intelligence. Entanglement is another quantum phenomenon that makes quantum chips so special. When qubits become entangled, their states are linked, no matter how far apart they are. Changing one qubit instantly affects the other. This property enables quantum chips to perform complex operations and share information in ways that classical chips cannot. Entanglement is key to quantum communication and computing, offering new possibilities for secure data transfer and powerful calculation. Quantum chips are built differently from classical chips. They require special materials and designs to maintain the delicate quantum states of qubits. Often, quantum chips are cooled to near absolute zero to prevent interference. The layout of a quantum chip is carefully engineered to allow qubits to interact and perform calculations. This intricate structure is what enables quantum chips to harness the power of quantum mechanics for computing. Quantum chips operate at extremely low temperatures. Cryogenic cooling is essential to keep qubits stable and prevent unwanted noise. Most quantum chips are housed in sophisticated refrigerators that reach temperatures close to absolute zero. This environment allows qubits to maintain their quantum properties, ensuring reliable performance. Cryogenic cooling is a critical aspect of quantum chip technology, making it possible to achieve the precision needed for quantum computing. Materials used in quantum chips are carefully selected for their quantum properties. Superconductors, semiconductors, and even diamonds can be used to create qubits. Each material offers unique advantages such as stability or ease of manipulation. The choice of material affects the chip's performance and scalability. Researchers are constantly exploring new materials to improve quantum chip technology and make it more accessible. Manufacturing quantum chips is a complex process. It involves precision engineering, advanced materials, and strict environmental controls. Tiny structures are etched onto the chip to create qubits and their connections. The manufacturing process must ensure that qubits are isolated from external interference. As quantum chip technology advances, new manufacturing techniques are being developed to improve yield and reliability. Quantum chips have a wide range of applications. They are used in fields like cryptography, drug discovery, optimization, and artificial intelligence. Quantum chips can solve complex problems that are impossible for classical computers. Their ability to process vast amounts of data quickly makes them valuable for scientific research and industry. As quantum chip technology matures, new applications are emerging every day. Quantum chips differ from classical chips in fundamental ways. Classical chips use bits that are either 0 or 1, while quantum chips use qubits that can be both at once. This allows quantum chips to perform certain calculations much faster. However, quantum chips are not better for every task. They excel at specific problems, such as factoring large numbers or simulating molecules. Understanding these differences helps us appreciate the unique strengths of quantum chips. Quantum chips face several challenges. Maintaining quantum states is difficult, and external interference can disrupt calculations. Scaling up quantum chips to handle more qubits is a major hurdle. Error correction is another challenge, as quantum chips are sensitive to noise. Researchers are working hard to overcome these obstacles and make quantum chips more practical for everyday use. Error correction is vital in quantum chips. Because qubits are so sensitive, even tiny disturbances can cause errors. Quantum error correction uses special codes and algorithms to detect and fix mistakes. This ensures that quantum chips can perform reliable calculations. Error correction is a major area of research, and advances in this field are helping quantum chips become more robust and practical. Scalability is a key challenge for quantum chips. Adding more qubits increases computational power, but also makes the chip harder to control. Researchers are developing new architectures and materials to scale up quantum chips. The goal is to build chips with hundreds or thousands of qubits, enabling even more powerful quantum computers. Scalability will determine how quickly quantum chips can revolutionize technology. Quantum chips can solve certain problems much faster than classical chips. Their ability to process multiple possibilities at once gives them a huge speed advantage. For example, quantum chips can factor large numbers or simulate molecules in seconds. This speed is transforming fields like cryptography and chemistry, opening up new possibilities for research and innovation. Quantum chips offer new levels of security. Quantum cryptography uses the principles of quantum mechanics to create unbreakable codes. Quantum chips can detect eavesdropping and ensure secure communication. This technology is already being used in some industries to protect sensitive information. As quantum chips become more widespread, they will play a key role in cybersecurity. Research into quantum chips is advancing rapidly. Scientists and engineers are exploring new ways to build, control, and use quantum chips. Universities, tech companies, and governments are investing heavily in quantum chip research. This global effort is driving innovation and bringing us closer to practical quantum computers. The future of quantum chips is bright, with new discoveries happening every day. Many companies are leading the way in quantum chip development. Tech giants like IBM, Google, and Intel are building quantum chips in computers. Startups are also making breakthroughs in quantum technology. These companies are competing to create the most powerful and reliable quantum chips. Their efforts are accelerating the adoption of quantum computing worldwide. The future of quantum chips is full of promise. As technology improves, quantum chips will become more powerful, reliable, and accessible. They will revolutionize industries from healthcare to finance. Quantum chips will enable new discoveries, solve complex problems, and drive innovation. The journey is just beginning, and the possibilities are endless. Quantum chips are poised to transform healthcare. They can analyze massive datasets, simulate molecules, and accelerate drug discovery. Quantum chips will help doctors diagnose diseases faster and develop personalized treatments. Their computational power will unlock new insights into biology and medicine, improving patient outcomes and saving lives. Quantum chips will revolutionize finance. They can optimize trading strategies, analyze market data, and improve risk management. Quantum chips will help banks and financial institutions make faster, smarter decisions. Their speed and power will create new opportunities for investment and innovation in the financial sector. Quantum chips will supercharge artificial intelligence. They can process huge amounts of data and train AI models faster than classical chips. Quantum chips will enable smarter, more capable AI systems. This will lead to breakthroughs in robotics, automation, and machine learning, transforming the way we live and work. Quantum chips are ideal for simulating molecules and chemical reactions. They can solve problems that are impossible for classical computers. Quantum chips will help chemists design new materials, discover drugs, and understand complex chemical processes. Their power will accelerate innovation in chemistry and materials science. Quantum chips can optimize logistics and supply chains. They can analyze complex networks and find the best routes for transportation. Quantum chips will help companies reduce costs, improve efficiency, and deliver products faster. Their computational power will transform the logistics industry. Quantum chips will enhance cybersecurity. They can create secure communication channels and detect threats faster. Quantum chips will help protect sensitive data and prevent cyber attacks. Their unique properties will make digital systems safer and more reliable. Quantum chips are powerful tools for scientific research. They can solve complex equations, simulate physical systems, and analyze massive datasets. Quantum chips will help scientists make new discoveries and advance knowledge in physics, biology, and more. Their impact on research will be profound. Making quantum chips accessible is a major goal. Researchers are working to reduce costs and simplify designs. Cloud-based quantum computing is making quantum chips available to more people. As accessibility improves, more industries and individuals will benefit from quantum chip technology. Education is key to understanding and using quantum chips. Universities and online platforms are offering courses in quantum computing. Learning about quantum chips will prepare the next generation of scientists and engineers. Education will drive innovation and help society harness the power of quantum technology. Collaboration is essential for advancing quantum chip technology. Scientists, engineers, and companies are working together to solve challenges and share knowledge. International partnerships are accelerating progress and innovation. Collaboration will ensure that quantum chips reach their full potential and benefit everyone. Quantum chips are transforming technology and society. Their unique properties like superposition and entanglement give them incredible power. Quantum chips are being used in fields from healthcare to finance, and their future is bright. As research, education, and collaboration continue, quantum chips will unlock new possibilities and shape the world for generations to come.